Good day, everyone. My name is Olaye Olasukomi Olalekan. Today, I'll be presenting on the topic titled Suction Characteristics of Polycyclic Aromatic Hydrocarbons in Petrochemical Industry Wastewater onto low-cost absorbent derived from low-density polyethylene. It has been of note that a huge amount of organic and inorganic pollutants has been produced in the wastewater over a few decades of time by this petrochemical industry through crude oil and refining processes. Wastewater generated from petrochemical industries contain a huge amount of hazardous and highly toxic materials, including polycyclic aromatic hydrocarbon, that is PAHs. PAHs are organic carbon and are mostly colorless, white or pale yellow solids in nature. They are ubiquitous group of several hundreds of chemicals related, environmentally persistent with various structure and varied toxicity. PAHs are pollutants of concern due to their carcinogenic, mutagenic, and toxic properties as recorded by various literatures. Natural sources of PAHs in the environment are insignificant. Among they are insignificant, and thus, owing to the environmental impact of PAHs, they must be treated and removed from the aqueous environment. So, among other methods, suction methods through the use of solid materials is found to be promising technique to treat or remove PAHs from aquatic environments in an economical and environmentally friendly manner. So, in this study, keratin was extracted from chicken feather, subsequently used to modify the low-density polyethylene, and which was invariably used as adsorbent. Keratin represents the major constituent of skin in its appellage, such as nail, hair, feathers, and wool. Keratin are proteins that form hard fibers and are present in wool, horns, and hooves, etc. And activated carbon is widely used to be is widely known to be the most effective and widely used adsorbent in suction treatment of wastewater containing high concentration of PAHs. So the main aim of this study is to explore the efficiency of low-density polyethylene, that is the LDPE, which was subsequently modified with keratin as a complementary conventional wastewater treatment method for PAHs removal, that is polycyclic aromatic hydrocarbons, in wastewater through the adsorption of PAHs from wastewater. This is in support of the Sustainable Development Goal 6 and Goal 14, which seeks to address the provision of clean water and sanitation, life below water, respectively. So the study produces activated carbon from low-density polyethylene, characterized, evaluate the adsorption efficiency of PAHs, and determine the mechanism of the adsorption using the adsorption equilibrium isotherm and kinetics. The main material, which is the LDPE, low density polyethylene waste, the chicken feather, and the cocoa pod hulls, which was used, were sourced from the Obafemi Awolowo Teaching and Research Farm and a local poultry establishment in Ile-Ife, Osun State, Nigeria. The reagents which was used for the experiment were all analytical grade. Carbonization of the low-density polyethylene and the cocoa pod hulls, that is the CPH, was carried out in a mofo funnels maintained at 1 hour at 500 degrees Celsius. The resulting char material was collected, cooled at a room temperature, and sieved to a particle size of 150 microns. The procedure was repeated for the CPHS, that is the cocoa pod hulls, at the temperature of 600 degrees Celsius, and was left to stand for 8 hours until ash content was obtained. The domain of variation of this factor is defined according to Bonema et al. 2007. The weight before and after carbonization was carried out in order to determine the percentage yield of the material. The extraction process of caustic alkaline salt and the keratin from CHF was carried out manually. The weight of CPHS was carried out, in which a a 20 gram of the CPHS was measured, manually stirred vigorously for 10 minutes, and was filtered with a Wattman filter paper, following the modified method of Okoya and Okoya 2009. This filtrate was boiled on a magnetic stirrer with hot plate at a temperature of 85 degrees Celsius and was left to stand for 6 hours. So the CPHS based caustic alkaline salt extracted was used in place of the analytical grade sodium hydroxide. This was done in order to prove to us that the analytical graded sodium hydroxide can as well be modified from a waste material from our environment. So the mixture was heated at this mixture of this cocoa products filtrate and the chicken feather was soaked in 100 ml of the solution. So the dissolved content was filtered after boiling using a Wattman filter paper and was centrifuged, operated at 4,500 rotation per minute for 10 minutes. The supernatant liquid was collected and filtered. Chemical activation process was carried out using a zinc chloride, which was used at the ratio of 1 to 10. The modification of the LDPE adsorbent was carried out, in which the keratin gel was diluted with deionized water and the mixture was continuously stirred, and at the end it was washed with distilled water, oven dried at 110 degrees Celsius. Characterization of the adsorbents were carried out using the FTIR, that is the Fourier transform infrared spectroscopy, the SEM-EDX, that is the scanning electron micrograph, energy dispersive X-ray, and the XRD as well was used in order to determine the functional group, the surface morphology, the energy, the elemental composition, as well as the crystallinity. So the extraction and concentration of PAS was carried out in order to know the amount of PAS which was present in the wastewater both before and during the simulation experiment. The recovery experiment was carried out in order to determine the matrix effect, in which the process involved the liquid-liquid extraction method as described by Okoya et al. 2020, which was adopted. The PAR was put into a separating funnel in which a DCM, that is the dichloromethane, was added, agitated for a few minutes, and the separation was formed, in which the aqueous layer was removed for analysis. Batch adsorption was carried out using the various parameters such as the initial concentration, the pH, adsorbent dosage, contact time, and temperature. Analytical measurements involve the use of gas chromatography, mass spectroscopy for the determination of the residual PAR both before and after adsorption. Adsorption isotherm model was as well used for this study, which include the Langmuir, Friedrich, Temkin adsorption isotherm. And as well, the study further checked for the kinetics study, which involved the use of the pseudo first order model, the pseudo second order, the Elovich. The study also involved the use of thermodynamic studies, in which was used. The results and discussion. Effect of carbonization temperature on the yield of low density polyethylene and the CPHS. In consideration, the carbonization temperature is known as a factor that is usually taken in consideration due to how temperature dependence of all properties on carbon material. So it's from the study, it was noted that the percentage yield, ash content and moisture content, volatile content, fixed carbon and pH of the carbonized LDPA at temperature of 500 shows that the percentage yield of 0.99 was discovered, the ash content of 2.8 moisture content of 1.5, volatile content of 23.4, fixed carbon of 72.3, and a pH of 6.95. The study proved that surface area of the pulverized CPHS increased after ashing, and this shows that the material is usable for this study. The chemical activation of the carbonized LDPE with zinc chloride was as well observed that an increased micropore area was discovered, given that zinc chloride plays an important role during the thermal degradation at high temperature. That is according to literature of the study of Rinewata et al. 2019. Characterization of the chicken feather-based keratin was as well carried out, in which the scanning electron micrograph at magnification of 15,000 gives a visible look of a honey layer, very thick and with small particles in aggregate. The extracted keratin from chicken feathers present a spheric shape, small microsphere with smooth surface consisted of a globally tight packed microparticles. And as well, the Fourier transform infrared spectroscopy, that is the FTIR, shows different peaks which correspond to such peak, such as the aldehyde, the aromatic, the carboxylic, etc. Hence, the FTIR spectra demonstrated the appearance of amino acid like the threonine, the chrysin, the glutamine in the CFHS-based keratin. So therefore, the study concluded that the obtained CFHS-based keratin possessed more B-sheet structure. And as well as the X-ray diffraction, shows different peaks. And in this study, it was confirmed that the B-sheet structure was more prevalent, which confirms that keratin was feasible to be extracted from the chicken feather. The characterization of the adsorbent, that is the keratin modified low density polyethylene activated carbon, as well as the unmodified low density polyethylene activated carbon, which is being represented as the KMLDPEA and as well as the ULLDPEA respectively. The scanning electron micrograph compares the surface morphology both before and after adsorption. And before adsorption, it shows a numbers of micropores on the surface of the adsorbent. And after, it shows that the pores were already clogged after adsorption process, confirming the adsorption styles, which tends to reduce, affirming adsorption has taken place, as well as the uptake of the adsorbate, which is the polycyclic aromatic hydrocarbons. The energy dispersive X-ray shows different elements contained on from the result. Oxygen was shown. Oxygen and carbon was more prevalent in the adsorbent, which shows that carbon is well pronounced, having the highest percentage of all elements detected. However, there are some presence of other metals in the adsorbent too, which is as a result of maybe during the process or from the raw materials. So, and after adsorption, it shows that carbon and oxygen are more prevalent in the surface of the adsorbent, and the functional group shows that the peaks gives a well result, showing that the results of the adsorbent characteristics obtained in this study is well compared and similar to other research. And the X-ray diffractions, which shows a numbers of peak from the adsorbent, confirming the result that it is evident that the adsorbent, it's more of crystalline in nature. And the physiochemical parameters of the wastewater was as well carried out both before and after adsorption. It shows that some parameters such as the temperature, pH, conductivity, true color, total suspended solid, the TOC, that is the total organic carbon, turbidity, etc., were all above the NESTRA guideline standard and the SON. The SON, that is the Standard Organization of Nigeria. The NESTRA, that is the National Environmental Standard Regulation Enforcement Agency. And for the PAR were observed to have a concentration of, for PAR, we have the naphthalene having a 0.03, and as well as the fluorine, while anthracene has 0.08, the fluorantine has 0.09, and the pyrene has 0.05. All these values are shown to be more than the NESTRA and the SON standard limit after the adsorption process. It was observed to be lower, which shows that the adsorbent is suitable for the treatment. Recovery experiment was as well carried out, which shows that the petrochemical effluents the PARs, such as the naphthalene and pyrene, has a recovery percentage of 100% respectively. The fluorine has 98, and while anthracene has 96, and for fluorantine has as well 96%. And after adsorption, it shows that the adsorbent were able to remove the adsorbate, that is the PARs, the naphthalene, anthracene, fluorantine, pyrene, and fluorine completely, which shows 0.0 concentration. And batch adsorption study, which involved the pH, at the end of the study, it shows that the pH of 7 and 8 was considered as the best pH for both adsorbents, with the least uptake capacity, which was observed at pH of 10 respectively. In addition, it is assumed that in acidic condition, positive ions occupies the active site of the adsorbent. Due to this, naphthalene, fluorine, anthracene, fluorantine, and pyrene ions have to face a repulsive force with a high concentration during the adsorption process. And for the adsorbent dosage, the adsorbent dosage of 0.2 to 1.0 was considered for the experiment, whereby it shows that at the adsorbent dosage of 0.8 and 1.0, the adsorbent, both the KML-DPA and the UML-DPA, were observed as the highest adsorption efficiency for the study. And for the contact time of 5 to 50 minutes was considered for the study. And it was observed that at the 50 minutes, there is, with increase in agitation, the lot of past ions was absorbed, having the highest percentage adsorption efficiency at 50 minutes. And for the temperature considers were 27, 32, and 37. From this range, it was observed, the study demonstrated that the absorption efficiency is inversely proportional to temperature. This could be attributed to an increase in temperature cliff, the bound between the adsorbent and the adsorbent, therefore reducing the removal efficiency of the adsorbent. However, it shows that at the temperature of 27, we have the highest adsorption efficiency, which from this study shows that at the temperature of 32 and 37, we have a decrease in the adsorption efficiency. And the effect of initial temperature, we have varied temperature, and from this study, it shows that the adsorbents were able to remove to show a tangible adsorption efficiency even at a very low concentration of a 0.01, and at the highest concentration it shows a meaningful adsorption efficiency as well, with both the adsorbent performed excellently. And the absorption study of the wastewater, all the parameters, the optimized parameter, that is the pH of 7, absorbent dosage of 1.0, the temperature of 27, 50-minute contact time, were considered for the absorption study on the field sample of water. And it shows that the adsorbent was able to remove PAS completely from this water. This study, however, confirmed the adsorption is an acceptable technique for wastewater treatment and purification as in relationship even in the tropical areas where this study was carried out. For the adsorption isotherm models express the equilibrium relationship that exists within the concentrations of adsorbate in the liquid phase and that on the adsorbent surface. It is useful in the design of adsorption system. From this study, the Friedrich, Temkin, and Langmuir adsorption isotherm was able to provide a better description of the adsorption processes. However, Langmuir has a better agreement and more favorable compared to other isotherms which were studied. And for the kinetics, the pseudo first order, the pseudo second order were used for this for the study, and as well as the Elovich kinetics. But from this study, it shows that neither the first and the second order were able shows a better result. However, Elovich shows that the study is in a consumption process and as well favors the adsorption processes. Inclusively, Temkin was used for this study in which to determine for the thermodynamic model, it represents the spontaneity and character of an adsorption process, which was used to determine the influence of adsorption process for PAR under study. And from this process, the study conclude that the equation from the study shows that the thermodynamic shows that the study is not spontaneity from the positive gig values, which shows the non-spontaneity of the adsorption process under consideration. And this suggests that the adsorbent has a high affinity, and this follows a similar trend with the work of Chen and Wang 2006 and Okoya et al. 2004. In conclusion, the study determined the suitability of the performance of the adsorbent, that is, the KMLDPE, keratin modified low density polyethylene adsorbent, and as well as the unmodified low density polyethylene adsorbent for the removal of PAR, such PAR in this study include the naphthalene, fluorine, anthracene, fluorantine, and pyrene for the simulated of wastewater under the influence of carbonization temperature and initial concentration. Furthermore, the adsorbent demonstrated outstanding adsorption efficiency for the removal of PAR and their derivative. The best adsorption condition such includes the pH of 7, adsorbent dosage of 1.0 gram, temperature of 27 degrees Celsius, and 50-minute contact time removed all the past considered. Langmuir isotherm was typically favored as expected since the kinetic proof it was chemosorption process. The thermodynamic study also shows that the process is non-spontaneous, and the study outcome gave credibility to solid waste, particularly the low-density polyethylene waste, chicken feathers and cocoa husk as the most promising activated carbon precursor, keratin production, and caustic alkali. As this solid waste could be harnessed, turned into wealth by being processed to serve as a cheaper and relatively low-cost source of keratin, alkaline salt, and non-hazardous alternative adsorbent to the commercially available materials for the treatment of PAS in wastewater instead of constituting nuisance to the environment. Thank you so much. I really appreciate the privilege to give this presentation in the VCCA conference of 2025. I wish you best of luck. Thank you very much.